Thank you to the organizing committee for letting me speak a little bit about some of our issues. Thank you for all of you coming out on this dreary day to celebrate science. My word of the day is change. Things change. If we were standing on this spot 20,000 years ago, which is only a blip in geological time, we wouldn't be seeing the trees starting to bloom or the lawn. We would be on the edge of a disintegrating ice sheet. And it would be more, it'd look and feel more like Antarctica than it does today. But even if you go back 200 years, even if you go back 200 years, you'd be standing on the edge. The environment would look similar, but you'd be standing on the edge of the Great Salt Cove, which would be right there where we wouldn't have a train station in the mall. We'd have an estuary. So things change all the time. Some environmental changes occur naturally over long time cycles, and others are our own doing, like filling in the cove for what was perceived to be the public good at the time. But things are changing in our climate, I think, as a lot of you seem to be aware. But how do we know they're changing? We know that because we've been measuring them for quite some time now. We're really lucky in Rhode Island to have a whole series of tide gauges in Narragansett Bay, and our Newport tide gauge, we've actually been measuring water levels pretty much continuously since 1930. So we have a good record of the sea level rise in Rhode Island. We also have a wave buoy southeast of Block Island where we're measuring wave heights. That one isn't as long a record, but it fills in an important gap so that we understand what is happening on our coastlines. There's also, don't forget the data that's being collected by the National Weather Service. They have Doppler radar that you can go right online on your phone and look at how long this rain is going to last, and it doesn't look that good. But anybody can go online and get real-time data for tide levels, for wave heights. This is very important if you're a surfer or if you're fishing, but it's also really vital for shipping and commerce, and it's important in my field for storm preparedness. But these data are also invaluable for determining long-term trends in sea level rise and storm conditions. So we know that our relative sea level rise in Rhode Island has risen like 9 or 10 inches since 1930. We're seeing more extreme rainstorms now than we have in the past. And on coastal storms, we don't know if they're getting, or if we're seeing more intense coastal storms. We don't have that certainty yet, but as we continue to collect data, hopefully in the future we'll be able to answer that question. So those programs are all administered by NOAA, but there's other important federal agencies that are monitoring things that we need, and NASA is a big one. NASA just doesn't look at outer space. They actually look a lot at Earth systems. And think of NASA as our eyes on the ice, on the great ice sheets. If the Greenland ice sheet were to melt, our sea levels would be 20 feet higher than they are today. And then if you were to melt the West Antarctic ice sheet, add another 20 feet. So under those conditions, I think I'd still be dry up here on the stairs, but all of you down there would be treading water. So it's an important thing to look at. Now, the ice sheets aren't going to melt overnight in time, but there are things happening on the ice sheets that are impacting our sea levels in Rhode Island. When you have the glaciers calving and you have meltwater, all that fresh water going into the ocean by the ice sheets is impacting the density-driven currents that we see. So and that's like the Gulf Stream. So as the Gulf Stream weakens, we're seeing water being pushed up against the East Coast. So our sea levels, our relative sea levels in Rhode Island are actually rising faster than the global average. Now, another thing about the ice sheets is they're very massive. They have a gravitational pull on the water. And as that as they lose mass, the water that is by the ice sheets starts to drop. But that water's still in the ocean basin, so it's very important to pay attention to where that water is going and how that's going to impact our cities and our state and our coastlines. There's additional data being collected by the Integrated Ocean Observing Systems. They use buoys and gliders and floating platforms to collect data on ocean changes in temperature, salinity, pH, algae blooms, and much of this data is available to the public in real time too. We're also doing things at a state and local level. We measure shifts in our shoreline with our shoreline change maps. We measure water quality, water temperatures in Narragansett Bay. We're looking at changes in salt marsh elevation and plant composition. And one of my favorites is there are citizen scientists who go out and photograph areas during extreme high tide so that we can see what's flooding and what will flood in the future under extreme sea level rise conditions. And we can use these to refine some of our models and sea level rise viewers. So why am I going on about monitoring? Because the data is really important to understanding what is happening now and what's likely to happen in the future. And although some of my skeptic friends may say that we're just making this stuff up, we're not. We need the data, good data for analysis and modeling. And as more data is collected, we can refine these analyses. There's always some uncertainty in science, but with good data, we can minimize that uncertainty. So we need to continue to collect good data and to understand what the future holds for us. Things are changing whether we like it or not. But if we have a good understanding of how things will change, we're in a much better position to adapt to those changes. So thank you.